problem, we're given several radical equations, and we are to solve them algebraically, and then check our answer graphically, and finally write our answer as an equation using either integer values or reduced fractions. Because the video is going to be a little long, I'm just going to do the first one. So to do it algebraically, the logic is that I'm going to eliminate everything except for x on the left-hand side by doing the inverse operation of each p. So for example, the first thing I see here is that there's a multiplication by 3, and I can undo that multiplication by doing the inverse operator, which is division by 3. 3 divided by 3 is 1. We don't need to write the 1. So the left-hand side would be 1 times cube root x plus 7. On the right-hand side, 12 divided by 3 is 4. Now I need to get rid of the cube root, and it turns out that the inverse operator of cube root is to cube. And what I do to one side, I must do to the other. So I'm going to cube the right-hand side, and I'm going to cube the entire left-hand side. And as I said before, the cube root and cubing operators are inverses of each other. They cancel each other out, leaving me with nothing but x plus 7 on the right-hand side. On the right-hand side, I have 4 cubed, which is 4 times 4 times 4. 4 times 4 is 16, and then by 4 again gives me 64. And then I need to subtract 7 on both sides. On the left-hand side, 7 minus 7 is 0. You could write plus 0, but no need. And then 64 minus 7 on a good day is 56. So checking my arithmetic, I think that's all looks good. Is it 56? 64, 57, sorry. Should be 57. So x equals 57 is the answer that I get. And you could either just plug it in the original equation, which what I would recommend is actually go back to the original equation and now plug 57 in for x and see if it does indeed give out 12. But the reason I'm not going to do that is I'm trying to make the video short, and it says to check your answer graphically. So I need to go to my graphing calculator and turn it on. Here's the on key. Go to your y equals, and we're going to type the left-hand side of the equation in y1. It's 3. The easiest way to get a cube root is to go to the math key and select option 4. So I've got the cube root of x plus 7. And I need to put a right parenthesis to let it know that x plus 7 is all, that whole entire expression is under the cube root. And then I'm going to down arrow in as a y2 second equation. I'm going to type in 12. So, I'm going to pretend I don't know that there's an issue here. I'm just going to start with a standard window. I'm going to graph this by pressing zoom, select option 6 for zoom standard. The standard window gives you a window from -10 to 10 on both the x and the y axis. The issue here, though, is that although this window looks good for graphing the first equation, the line y equals 12 is basically an equation where all the y values are 12, which means I'm going to get a horizontal line up at 12, but our window only lets us see as high as 10. So step 1 would be go to my window, go down to y max, and say, hey, I want to see higher than 10. Since my graph goes horizontally through 12, let's go a little higher and say 15, and regraph it. This way, y equals 12 is actually viewable in my window. So if that wasn't enough, now I'm wondering if my x values in this window are large enough to contain the solution, meaning I haven't given it a sufficiently large x value enough for this graph to grow to a y value of 12. So now I need to hit window. My current x max is 10, and I want it to be bigger. So this x max controls how far to the right you'd see. So I would usually try 20 or 30 and guess, but I've already done the work. I know the answer is 57, at least after I corrected my arithmetic, right? So I'm going to cheat a little bit. So since I know the answer is 57, I'm going to go at least a little higher and say 60 or 65. I'm going to go 70 and regraph it. And if you go that far to the right, you're giving enough time, if you will. You're large enough x values to let this grow high enough that it's going to surpass 12, or at least meet it. Now, to actually see that they intersect, you'd have to run the intersect feature, which is in this calc menu here, which happens to be the second function. So I would click second, click the trace key, so I'm actually accessing the calc menu, selecting 5 for the intersect feature, and the solution to the equation, and this works for equations other than just radicals, would be the intersection of those two. It starts, to run the feature, it starts by asking a couple silly questions. Is this the first curve you typed in? We say yes by pressing enter. Calculator does not accept voice commands. It pops to the second curve. Is this your second one? Yes. Enter. It asked me to guess where the intersection is. This is important. If you had multiple intersections, you would need to move. It can only find one at a time. You'd have to move your cursor to the one you want. So, for example, if you had two curves intersecting in two different places, and you wanted the one on the left, you'd have to guess the one on the left. Move your cursor and guess towards the left. If you wanted the intersection at the right, you'd have to trace over and put your guess to the right. It can only find one at a time. But in this case, I can just press enter. I don't need to go through that. There's only one intersection, and there it is, 57. See, the calculator has no trouble with arithmetic like I do. The x value is 57, and it checks with my answer. Remember, if you type in 57, you will get it wrong. If I press preview, it says syntax is okay, but it says that you have to write your answer as an equation solved for x. This is not an equation. Because there's no equal symbol, so it does not constitute an equation unless you have an equal. So x is equal to 57 is what needs to be put in there.